Here we have a drawing of a box or a rectangular prism that's drawn in two-point perspective. And we did this as a class exercise, so this ought to be easy. We're going to identify a few of the lines here. We're going to look at lines perpendicular to CD. Let's first identify CD with this orange line. And I can see I've got the right angle tick mark, so I can see perpendicular lines several places. On the top plane, or the blue plane, I'm seeing AD, and I'm seeing BC. Now in the vertical or yellow plane, I see DH, and I see CG as well. So right there, we've got we have 4 different lines, indicating lines, and they are existing in 2 different planes. Okay, let's move on. Number 5, how about lines that are skew to that same orange line? Well, skew, if I'm looking at this one, BF, it is not intersecting and they are not parallel. They're in different planes. So that one looks like a skew line, and so does this one. Incidentally, those 2 lines are parallel to each other, but they're both skew to the orange line, just as the ones on the floor, if you want to call it, the bottom plane, EH, and also on the bottom plane, FG. So I would see 4 lines right there, and those are all skew, non-intersecting and non-parallel. Okay, well, let's move beyond that, and let's even get rid of the lines, and let's talk about planes. What plane is parallel to this plane? And CHD is it's referring to this yellow plane. Remember, any 3 of the 4 letters uniquely identify it. So I'm going to take this plane and project it this way. And right about there, I'm going to see it's that backside, or let's say if you will, it's one of the planes that's in the background in our drawing, and we'll call that one ABF, or EAB. Any 3 of those 4 letters would be sufficient. And there you have it. Now let's identify some angle pair relationships. I'm going to start with the blue line, and I'm going to draw somewhere on there a purple line. When I cross these 2 lines, I'm going to cross them with a transversal, the line that intersects the other 2. Now, with this, there's going to be many different associated angles. As a matter of fact, I can see I'm generating 8 different angles in this diagram. It should be said here that no one said anything about parallel. So we don't know that these lines are parallel, and for our sake, we'll say they're not. Let's move on. Okay, I'm going to look at these 4 angle pairs. In our textbook, this is exercise 11, 12, 13, and 14. And we're going to say corresponding angles. We see them in the corresponding position, if you will. Again, the 1 and the 5. Again, no one said they're congruent. That comes later. Look at a second pair. So I've got a pair there. I've got a second pair. I've got a third pair. I've got a 4th pair. Okay. Alternate interior angles. Remember, this is the interior. It's the interior region between the 2 lines that are crossed by the transversal. If that's the interior region, and we're on alternating sides of the transversal, I've got 1 set there, 4 and 5, or I've got 3 and 6. Okay, well, if it's not on the interior, I guess it's on the exterior. On the alternating sides of the transversal, 1 and 8, 2 and 7, right? And 1 more set. Again, back to the interior. These are all on the interior, but they're on the same side. Consecutive interior, 3 and 5 are on the same side of the transversal, on the interior of the 2 lines crossed by the transversal. Ah, say that 3 times fast. So now we got that one, and we've got 4 and 6. And there you have it. You've got all the angle pair relationships of 2 lines cut by a transversal. Well, here we have 16 numbered angles that are generated from the intersection of these 4 lines. And we're going to identify several angle pairs. Let's start with 5 and 1. This is number 18 from your exercises. So I'll do it this way. I'm going to hide from my mind everything that isn't angle 5 and 1. I can see I don't need this line here because, in fact, this line on the left is my transversal. These angles are in the same corresponding location, so I'm going to call those corresponding angles. 1 and 5 are corresponding. Let me restore the drawing briefly. And now for angles 6 and 13. I'm going to take away everything that isn't 6 and 13. I see these over here. I'm going to take away this line, which isn't relevant now, because this is my transversal here. My transversal runs this way. These 2 angles are on the interior, and they're on the same side of the transversal. So I will call those consecutive interior angles, right? Getting the hang of this. So let's do one more. Restore the drawing. Let's look at 2 and 11. Angles 2 and 11, well, they would be up here. And I'm not going to use this line down here. This is my transversal. 2 and 11, they're on alternating sides of the transversal, still on the interior of the lines being crossed by the transversals. Those are transversal, so they're obviously known as the alternate interior angles, right? I think we're getting pretty good at this. Oh, I love these sometimes, always, never questions. We're going to borrow this figure from an earlier exercise to help us illustrate. So let's start with 24. If 2 lines are parallel, then they are coplanar. Well, let's just take a sampling. We'll just say AD. Well, I guess BC is parallel to it. And you can see that that occupies that blue or top plane. Okay? Well, EH is also appears and is parallel to AD. And that is clearly in this green plane. What about this one now? FG. I'll try to draw that in there. They are parallel. And in fact, yes, they are in coplanar. We just don't see the plane. Imagine that plane exists on a diagonal, but we could pass the plane through there. This is going to be always, always, always true. This will, in fact, be one of the ways that we identify a plane. And it can be identified, in this case, by a pair of parallel lines. All right. Well, let's get enough of that. See if I can get rid of these off the drawing. And let's go back and look at the next one, 25. If 2 lines are not coplanar, well, let's draw a couple of lines that aren't coplanar. I'll start with AD again. Let me see, this one's coplanar, these intersect. Well, here's one that's not coplanar. And let me see. Well, they can't, and they don't intersect. All right. I'm trying to think of others that aren't coplanar. Any of the ones that aren't coplanar, they're going to have to be skew. So right away I'm seeing a problem here. I'm looking at 2 lines are not coplanar. Well, I'm going to say they never intersect. Notice the converse of that statement is not true, because if 2 lines never intersect, they could be parallel, or they could be non-coplanar. Now, if 3 lines intersect at a point, okay, let's look at 3 lines at a point. I've got 1, 2, 3. I've got 3 lines that are intersecting at D. And I'm saying, well, that clearly shows a counterexample. Those are 3 lines intersecting at a point, and they are not coplanar. But could they be coplanar? Of course they could be. I could just draw the line BD on the surface, and you can see now that AD, BD, and CD are they're all going to be in that top or purple plane. Maybe I can illustrate that better by getting rid of this one. And all three of those would be in the top plane. So I'd have to say that gets a definite sometimes. Now, if two lines are skew, well, hang on, we need to clean up this drawing. Get rid of this, this, and this. If two lines are skewed to a third line, what are they to the other? Well, this drawing may not be sufficient because I'm going to say this one is skewed to this one, and this one, I guess this might work. So BF is skewed to AD the same way that HG is skewed to AD. And they are skewed to each other. This is an example of, yes, they are skewed to each other. So it looks like the transitive property of skewness, if there was such a thing. So those two both are skewed to AD. However, I could do this. Let's change this. I'm saying BF is skewed to AD, but now I'm going to say CG is also skew to AD, and you're going to say, wait a minute, these two are parallel. So that's going to get the definite sometimes. They are sometimes skewed to each other because they could in fact be parallel. They could in fact intersect. I mean, I could have had it on the back across this back plane in some other orientation. But in either case, that's going to get a rating of sometimes. Now this is a useful diagram. We're going to see a lot of these in the next coming chapters. I've got some quadrilateral with a diagonal or two triangles, and I'm asked about these two angles. I'm looking at RPQ and PRS. Well, first I'm going to number them. Sure, you can do that. You can do whatever you want in geometry. I'm just going to call them 1 and 2 because it's easier to see. So you got that, RPQ, yep, that's 1. And let me say PRS, that's number 2. So the question is, what kind of angle pair are they? And don't say congruent because nobody said anything about these being congruent. That's not an issue here. It is the relationship that we've been talking about with the angle pairs. Matter of fact, I'm going to make it purposely look like they're not congruent. So angles 1 and 2. Well, if I were to draw on these lines, just if you look at both of these angles are bounded by PR, SR, and PQ. If I were to draw those lines in, the figure would become more clear. Looks like two lines cut by a transversal. If I were to further hide those, completes the picture. And it's pretty obvious now that these two, 1 and 2, are on the interior between the two lines, and this is my transversal. So that would have to be, let me see what I got. There you go. Alternate interior angles. This is going to come in handy in the proof set we have to follow. Well, this is the big one, the parallel postulate. It may be Playfair is the way we say it here, but I've got a line L and a point P not on that line. And I can draw exactly one line parallel to L passing through P. And that's it. There's only one. That's what makes our geometry special. We will put the little tick marks on there, and you'll see those the rest of the book, and those are going to indicate that the lines are parallel. Well, the perpendicular postulate works the same way. For a line L and a point P not on L, there's exactly one line perpendicular to L passing through P. I left this up here, though, so you could see in this plane, this also represents the minimum distance between a point and a line. By definition, the perpendicular distance.